Good morning all. We are discussing about Biot-Savart law. Let us see a problem using Biot-Savart law. Find the magnetic field at the center of a square loop which carries a steady current I. Let R be the distance from the center to side. This is shown in figure A. We have a square loop that carries a steady current I. We have to find out the magnetic field at the center, that is at P. Now P is at a distance S from AB, BC, CD and DA. Now to solve the problem, let us consider a wire segment AB, and this is represented separately in figure B. And we can see a triangle ABP there with AB, this is equal to R, and P is at a distance S from AB. Now what is the magnetic field at the point P due to this wire segment AB? In the last problem, we have seen the magnetic field due to a wire segment carrying a current I, and we have arrived at the result, and we are using the same result here to solve the problem. We have seen that the magnetic field at P due to the segment of the wire carrying current I is, then using Biot-Savart law, it is given by B is equal to mu 0 I by 4 pi S sine phi 2 minus sine phi 1. We have seen this result in the previous problem. Now let us look into the triangle ABP. From the triangle we can see that the angle phi 2 and angle phi 1 both are pi by 4. From the triangle ABP, phi 2 is equal to pi by 4 and phi 1 is also pi by 4, but if we consider the direction in which the angle is measured, and usually the angle is measured in anti-clockwise direction, then we can say that phi 2 is equal to pi by 4 and phi 1 is equal to minus pi by 4. Thus B is equal to mu 0 I by 4 pi s sine pi by 4 minus sine minus pi by 4. Now sine minus theta, this is equal to minus sine theta. Therefore B becomes mu 0 I by 4 pi s 1 by root 2 plus 1 by root 2, that is equal to mu 0 I by 4 pi s 2 by root 2. Now from the triangle we can see that S is equal to R by 2, if where R is the length of the side of the square loop. Now substitute the value of S in the expression, you will get B is equal to mu 0 I by 4 pi, S is equal to R by 2, then 2 by root 2. This implies B is equal to mu 0 I by R by root 2. This is the magnitude of the force, magnitude of the field. B is equal to mu 0 I by R by root 2. Now what is the direction of the magnetic field? It is directed into the plane of the paper. This is the magnetic field at the point P due to the segment AB of the wire. B is equal to mu 0 I by R by root 2, where R is the length of the wire segment AB. But in the problem, it is given a square loop with the sides AB, BC, CD and DA. And if we consider the square loop as a combination of 4 wire segment, then the magnetic field at the point P is the sum of the magnetic field due to the wire segment AB, BC, CD and DA. Hence, the magnetic field due to the 4 wires, or simply the magnetic field due to the square loop carrying a current I, is given by 4 into mu 0 I by R pi root 2. The present case we have seen a square loop, that is a square which has 4 sides. Now let us extend the problem to n-sided polygon. You consider an n-sided polygon which carries a steady current I. What is the magnetic field at the center of the n-sided polygon? And you assume that A be the distance from the center point and to any side of the n-sided polygon. Now, if we generalize the problem, then the phi 2 is equal to minus phi 1. This will become pi by n, pi by n. If it is a square loop, then phi 2 is equal to minus phi 1 equal to pi by 4, that we have already seen. So in general, for a regular n-sided polygon, phi 2 is equal to minus phi 1 is equal to pi by n. Therefore, the magnetic field at the center of a regular n-sided polygon is given by B is equal to n mu 0 I by 2 pi a sine pi by n. Now let us consider another case. What happens when n tends to infinity? You have a regular n-sided polygon. When n tending to infinity, the shape becomes circular. Now what happens to the magnetic field? Now the problem reduces to the magnetic field at the center of a circular loop. When n tending to infinity, it is clear that the phi becomes very small. When phi is very small, sin phi can be approximated as phi. Therefore, sin pi by n can be approximated as pi by n. Hence, in the previous equation, B becomes n mu 0 I by 2 pi a into pi by n, which is equal to mu 0 I by 2a, which is the magnetic field at the center of a circular loop.